Hey, what's up, guys? Chung here again. So, so this time let's take a look at another problem in this week's weekly contest. Number 1578. Minimum deletion cost to avoid repeating letters. Okay. Mm. So you're given like a string s and an array of integers cost, where cost I is the cost of deleting the character I in s. Okay, basically you have a like same two. You have one string and one cost arrays, whose length are the same, and you need to return the minimum cost of deletions such that there are no two identical letters next to each other. Okay. Mm. And notice that you will delete the chosen characters at the same time. In other words, after deleting a character, the cost of deleting others characters will not change. Okay. Mm, so for example, right? So in example one here, and there are like two A's here, okay, and which means you need to delete one of the A's, right? But which one? Since the cost of deleting those two A's are either 3 or 4, that's why we chose 3 here. Okay. And for this in the example 2 here, since the as itself by nature it's not does not include any duplicated letters, that's why the cost is 0. And for example 3 here, right, we delete the first A and the last A, which has which have the least cost, which will be 2 here. Okay, and the the length of the cost is 10 to the power of 4, which means uh, it has to be a on or like on log n. Okay. So, at the beginning, I was thinking about if I should you actually I struggled at this problem for a while because I was having hard time to determine which approach I should use. You know, I think first I was like, should I use like a binary search? Can a binary search work? Basically, if I search the cost, right? If I search the cost, but then I have to, then probably not because of binary search, I need to use the midpoint cost, try to remove the letters. That it, basically it basically cannot be solved. And the next one, I was struggling a lot by trying the DP solution here because I was like, should I use DPI here, right? Like DP I such that, the DPI means like by uh from 0 to I, right? What's the minimum cost? Okay. And then I'm trying to come up with this like the state transition functions, right? Basically, if the DPI, I'm like because for DPI and to get the DPI here, I will need to somehow get it from the DPI minus one, right? So which means like uh, I think for the DPI, if basically if the I is not the SI uh, does not equal to the SI minus one. Okay, something like this. Because I was in that path like for a while. Basically, if the current letter is this it's not sorry, it should be the same. Okay, if those are the same, it means that we somehow have to move remove one of them, right? Yeah, basically if I move, but then how can we determine which one I need to remove, right? And if I remove the I minus one, and then I don't have to remove the S here, right? And then I was like, should I create two DP arrays? One is for the delete, one is for the not delete. Yeah, but then I think I just simply got stuck there. Because let's say, for example, if we have a a, right? Let's say we have four A's here, and the cost is 3, uh, 2, 1, and 4, right? So if this is our input here, uh, can we use the DP here, right? Basically, at each of the DPI here, right, we compare. Okay, so A is the same as the previous one. Then I need to determine like which one to remove. Basically, I was like, okay, if there are two options, I can either remove the previous one or I can remove the current one. Okay, but after doing that, right, when I add this like the next one, the I plus one here, when I add the I plus one here, uh, if this I has already been removed, right? How can I how can I link how can I link this I plus one with the previously result, right? Yeah, basically I was having a hard time of that. Mm. I mean, if you guys come up with the DP solutions, I'm more than happy to know that. Yeah, because I just couldn't come up with the DP solutions for this problem, and I got stuck there for a while. And then I was like, okay, fine. Can I try a different way? Then I just started looking at this problem one more time, and then I realized that every time when you have like more than one letters, or every time when you have like duplicate letters, what's our best strategy, right? So the strategy is let's say we have four A's next to each other. In the end, we will need to remove three of them, right? Because we only want one A left. But then how can we remove? So which three we want to remove? Then the problem becomes much easier. Basically, we just need to remove uh, the cost, the least cost. Basically, we will leave the ones that has the highest cost, and we'll remove all the rest, right? Okay, so then the problems also it break down to the every time we have like a duplicated numbers here, we will remove everything, but then in the end we add this 4 back, right? And of course we need to maintain like a maximum cost while we're looping the array, right? So that in the end we know, okay, which cost we need to add it back. And then furthermore, like if you think it more, like basically we can apply this like logic to all of the cost here. Basically, while we're looping through the S here, right? Every time we have a letters here, we remove it. Okay, sorry, we're adding the cost to our final answer, and every time when we switch to a different letter, okay, then we just add that maximum cost. Sorry, we're not adding. Basically, since we have an answer here, right? Basically, every time we're adding like a cost I, okay, and then every time when we reach every time when we like switch to a new letters, we just simply uh, remove that max cost from the answer, which means that basically we're adding that letters back, right? Since this is the cost answer here. And this will also work for the one letters, because let's say for the A, B, C, and D, right? Basically, let's say we're at 1 here, right? We're at 1, and then we remove 1. So basically the answer will becomes 1, okay? And while we're looping through the letters, we're also maintaining the max cost, okay? And now we're at B here, and now we see, okay, B is not the same. Yeah, so B is different as the previous one. Then we know, okay, we're at the different letters now. Now I just need to remove I just need to remove that. Remove this like one, the previously max count from our answer here because there's only one letter and the max count is the letter itself. That's why we can simply remove that, right? Basically, we remove it back from, we remove the max count from our final answer. And then we add B here. So at B here, we're also like, so now the max count becomes to the cost of B, which is 2, okay? Yeah, and then we just keep going until at the end, basically, we just the answer will be 0. Basically, every time when we add a new number, a new letters here, we remove the max count for the previous one. Okay. Yeah, I'm just so here it's also we'll also handle this single letters here. That's why. So when they let's say for this example here, so when we're at 1 here, right? A letter A here, the answer, right? The answer will become 1, right? And then we're at the second A here, the letter will becomes to 3, right? Because 1 plus 2 is 3. When, but okay, so and now the max count is 2, right? Now we're at B here. So the B is like it's a new number. It's a new letter. That's when we remove the max count, right? For of the previously maintained max count, which is 2. So now the answer becomes 1 here. Okay. And then the B, then we remove the B, right, from the from basically we add the cost of B, which is 4, right? So it's 4. And then now it's A. So A is different as B. So now we just remove the 4 and it becomes 1 again. Okay, right? And then the next one, uh, the next one is 4. It is 5 because the cost is 4. And then the next one is 6. Yeah, it's 6. And since it's reached the end of the array, we simply remove the current max one, which is 4, and now it's 2. Okay. Yeah, basically that's how this solution handles both the single letter and the last letter. Okay, enough talk. Let's try to code these things up here. Okay, so first we're gonna have like a length here, right? And then the answer equals to 0, and I'm going to maintain like a max cost. Okay, so basically when I in range n, right? So what we're trying to do here, so like I said, every time basically we're removing the letter regardless, right? The cost I, and we're also going to maintain this cost. Okay, max cost cost I. Okay, now let's do a simple check here. Basically, if the S I uh, is not the same as Si minus 1, uh, oh sorry, actually I think mm, so I think when I go through this algorithm, sorry, I think I shouldn't have said looking back. What I meant was I should look forward. Basically, when we add this A here, we check when we add A when we look forward one by 1. Sorry, so basically I'm I plus 1. Okay, I mean Si and Si plus 1. So which means here we need to check we need to make sure, right, the I plus 1 is not out of the boundaries. So basically every time we have like letters, we're looking we're comparing with the next letter. Basically, if they are different, right? Then we know, okay, so we're done, right? So current I, we're done with the current group. We can remove the max cost for the current group, okay, which is the answer minus the current cost, okay, and then don't forget to reset the max cost to 0 so that the next loop will just basically update the max cost again, right? Yeah, and then in the end, we simply return the answer. Yeah, that's it, I think. Cool. So, yeah. Mm, yeah, sorry about the confusion. Yeah, about the confusion. Basically, Um, I think the key idea for this problem is that you just have to find the right direction to solve this problem, which is simply like it's nothing fancy. It's not really about the DP or the binary search. It's just about like you just need to find the groups, right? The group of the duplicates, and then while traversing the groups, you maintain like the max count, sorry, the max cost for that group. Of course, a single letter also counts as a group, okay? And you maintain the max count for that group. And when you when you see the next one is different than the current one, then you know you are at the end of this current group. And all you need to do is you just need to remove the max cost uh, for the current cost from the answer, which means we are adding that letters back, right? So that then the rest will be the cost we removed for the current group, and in the end we simply return the answer here. Yeah, I because when you guys see this code, it's pretty obvious, right? It's not that hard, but when you are trying to approach these solutions by yourself, and I think you guys just have to be more flexible. That's all I can say that here. Be more flexible and try to really think this problem in a different approach, right? If one approach doesn't work, probably that's not the right direction. Then you have to look at this problem in a different angle, right? Or different perspective, which is the is simply like categorize uh, these strings into different groups here. And for each group, you just you only need to re, keep one letter, right? And then the problem becomes much easier. So which letters to keep? Of course, is the letter with the highest cost. Okay, right. So with that, you can probably it shouldn't be that hard to come up with this solution or something like this. Okay, cool guys. I think that's it for this problem. Yeah. And oh, sorry, the space and time complexity. Yeah, I think it's quite obvious, right? So it's time complexity is O of n, right? And space is O1. We're only using like a constant one variables, right, to store the max count. So O1 space. All right, sorry guys. Cool. Thank you so much for watching the videos, guys, and stay tuned. See you guys soon. Bye bye.